Good evening, Mindsetters, and welcome to Learn Extra Live. You're here with Tara, and I am in studio with John. Hello, John.
Hi, Tara. Guys, great to be with you again. And of course, the reason that I'm here is that Peter is away. You know, he's gone to Disneyland.
Oh, no.
Can you believe it?
And he didn't take us.
And he didn't take us.
There we go.
I hope he's bringing something for us. So maybe we'll see and hear from him in a week or two's time.
Oh.
He's due to be back, not next week, the week after. Tell us all about his trip, I'm sure.
Oh, definitely. I look forward to hearing about it. What are we doing today? I think
Okay, so what we're doing today is we're talking about probability. Probability we introduced last week. Today we're dealing with probability problems. Now some of these can get quite tricky, Tara.
Definitely.
But we're going to work them out. We're going to be looking at things like tree diagrams and some interesting ideas. So don't leave your seats. We're ready to do something quite good.
Definitely. I look forward to this. I enjoy math so much, and I hope that you guys do too. Before we get going, though, I want to quickly tell you about an awesome competition that we've got running. It's sponsored by Vodacom. It's called Get Connected. And we've posted a link on Facebook for you to follow and everything, but let me give you a little bit more about what you must do. Your first step is that you must follow the link, and it'll take you to the career page. They'll ask you for a code, which you can put in as learn, upper case or lowercase, doesn't really matter. And then you select your favorite teacher and submit. After that, you must come back to the Facebook page and like the image of your most favorite teacher. And the third step is that you must share. You'll see there's an image. You must share that image, and then you're sorted.
So that's the one at the top of the page.
At the top.
Graphic
You
there.
can't miss it.
Yeah.
And it enters you for an awesome competition. You can win a Sony Xperia or airtime, which I think is absolutely amazing. So definitely get onto it. And that's all from me.
Well, Tara, you know what? The important thing about this, that competition we've been running for the last 4 weeks or so. This is the end, the last chance to get this round of teachers through. So guys, you better get voting, because we're going to close this off. We're going to be doing the draw on Monday.
Okay.
So make sure that you've voted, you've got your votes in. It's actually quite tight. The number of likes between those teachers is actually really very close. And if you want to win the Xperia, then you're going to need to make sure that your teacher gets the most likes. Okay, so there's also airtime, and that's going out as we're speaking. Okay, guys, let's get into this probability story.
Let's go.
And let's get going with it. What are we going to do? We're going to, as I've said, we're going to, first of all, we're going to revise to find out the probability of an event taking place. We'll look at that. And we're also going to apply our knowledge of probability. Let's get straight into our challenge question. And as usual, for the last couple of weeks, I've been doing challenge questions that involve Peter, just because we miss him so much. So here's an interesting challenge question for you to think about. Here, let me go through it with you, and I hope you agree with me that you enjoy this idea. So Peter takes his wife and DJ, their son, to lunch at Disneyland. Okay, the menu, because it's in America, has 32 different types of hamburgers. Okay, he and his wife cannot decide what burger to order, but DJ really wants the chef special, and that's number 10 on the menu. So what do you do when you can't make decisions? I don't know if you like that, Tara. Can you make decisions easily?
Majority of the time, but when I don't, I think
you have
it
to
becomes
take some
very
time.
tough, yeah.
It becomes quite difficult. So Peter thinks, well, here's a strategy for making a decision. He takes all the numbers, 1 to 32, writes them on a piece of paper, puts them in a box or into a bag, and then he draws them out. That's exactly what it says. So he writes down numbers 1 to 32, puts them into a bag, and then he draws out 3 different numbers. So listen carefully. Puts his hand in, pulls out a number. Puts his hand in again, pulls out a number. Puts his hand in again, pulls out a number. Now remember what DJ wanted. DJ, their son, he wanted number 10. Okay? And what the challenge question is, what is the probability that DJ will get a chef special? Let me not confuse that. What probability out of those 3 draws will one of them, because Peter and his wife are loving parents, if one of them ends up being number 10, who do you think is going to get it? Do you think DJ or Peter? Well, don't say Peter. I'm sure DJ was going to get it. He's going to make sure. His bag's number 10. He really wants number 10. They don't really mind what the other burgers are. So, can you calculate the probability? Interesting question.
I think so too. Very,
Okay.
very tasty question.
Tasty makes you hungry. Now, guys, we're dealing with a bit of food tonight as well in all our questions, but I just want to remind you a little bit about probability. And so we're going to start with a blank sheet, and I'm just going to expand on that and remind you about certain things about probability. And let's go and do that. If we have a number line like that, and we recognize that on that number line, let's make it a bit thicker, you have 2 extremes. The chance of something being impossible, that's going to have a probability of 0. The chance of something being definite, probability of 1. Remember, we can write it as a number between 0 and 1. That could be as a fraction. So we could say the halfway point is 1 out of 2. Or we could write it as a decimal, 0.5. So that's one way of representing probability. The third way that's quite common is to do it as a percentage. So instead of writing 1 over 2 or 0.5, we could say the probability is 50%. That's like if we were flicking coins up and down. Sometimes it might be a head, sometimes it might be a tail. But 50% of the time, if you did it for long enough, would end up being heads. 50% of the time would be tails. So what's the probability? It's 0.5 or 1 out of 2 or 50%. All of those are acceptable. Now I want to remind you, and this is very important, what our definition of probability is. So we're going to say probability is equal to the total number of events divided into the number of things that we want to happen. And we call those favorable events. So in DJ's case, it's the number 10. What's he want? He doesn't just want any old number. Roz and Peter don't mind which number is drawn out. But DJ wants 10. How many possible things can he get out of the box? Well, there are 32 possibilities on the first draw. Okay? But he just wants 1 out of 32. What about the second draw? Well, you think about it. Right, so that's how we calculate probability. Now, Tara,
Yes.
I want to just illustrate something. So
Okay.
can you leave your perch over there?
Yes.
And come and stand next to me.
Right.
Because we've got some things in the box.
Oh,
here.
yay.
You don't know what
Okay.
there's in the box. But I'm going to say to the learners out there that what we've got is a collection of different colored balls.
Okay.
There's a blue one, there's an orange one, there's a red one, and there's a green one. Okay? So if I count the total number of things in the box, there are 4. Okay? So close your eyes and put your hand in and don't show me what the color is.
Okay.
Okay? So Tara's taken 1 out of the 4. They were all different colors. So what's the probability that the ball that she's got in her hand is a red ball? What do you think? Remember, we had 4 balls. So we had 4 in total. And she's just taken out of 1. What's the probability that there is, that she's got the red one? Think about it. Let's see what's in your hand. Orange.
Orange.
So we didn't get the red one. Okay? So if we think about it, we could carry on and put the orange one back. Put the orange one back for the moment, because we're replacing the orange one. I'm going to shake it up again, and let's see what the options are. Have another go.
Okay.
Don't look.
Let me get this all. Okay.
Pick it out. And let me see what color it is. And it's the pinky red one. Okay. So, guys, in 2 shots, Tara's picked out the one that we really wanted. But what I want you to see is it doesn't really matter because we only had 4 bulls. There was only one that was really the favorable one. She really had a chance of 1 in 4. Because she could have carried on picking out balls and they might not have been the right one. But now, let's put this one on the side.
So
how many balls have we now got in the box?
3.
We've only got 3. So we're not replacing. We've only got 3. So remember that. So now what do you think the probability of picking a red ball is?
Well, if we've taken one out,
Yeah.
and do we know that it's the red?
Yes, we know it's the red.
Then it's none.
None.
There's 0.
There's 0. So we could stand here forever and we would never get the red ball because the red ball's not in the box. Okay? It's like we know definitely, okay, that there's never a chance. It's impossible. Probability is 0. Do you agree with that?
Yes, definitely.
Okay. So let's pick another one out.
Okay.
What's the probability of getting a blue one? Remember there are 3 in the box? What's the probability? Pick one out. Oh, the orange one again.
I'm no good.
Now, what's the probability of getting the blue one? Well, we said there were 3 and it's 1 out of 3. What's the probability of getting the orange one? 1 out of 3.
Yes.
Okay. I'm going to leave the orange one there because we're going to ignore it for the moment. How many have we got in the box now?
We've only got 2 now.
We've got 2. Leave it.
He wants to be part of this.
He wants to be part of it. Okay. Put the hand in and let's pick out. You got the blue one. What was the chance of getting the blue one? Well, there were only 2 balls in the box, so it was 1 out of 2. Got it. Now, there is 1 ball left in the box.
Yes.
So what's the probability of Tara getting the green ball? There's a green ball in the box. What's the probability?
Absolute. It's 1.
It's 1. Can you see? It's absolutely, definitely 1. So if she puts her hand in the box, 1 out of 1 chance of getting the green ball. There's no chance of getting another colored ball because there was only 1 ball in the box. It's like saying, what's the probability that the 25th of December is Christmas Day? It's certain, isn't it?
Set.
There's
Yeah.
no chance that Christmas Day is not going to be on the 25th of December. Okay. So I hope you're getting to understand this idea of probability. Those are the simple calculations. Now, we're going to do a couple more that require us to do more than one thing. So not just taking 1 ball, but perhaps taking 2 balls. Perhaps asking the question about, should I take this one or this one and that one? Those are choices that make it a little bit more difficult.
And very important.
And they're
to
very
the
important,
probability.
absolutely. Okay, so guys, I think I'm going to get straight into a question. And with that little bit of introduction, we're going to do a simple question, first of all. Thank you, Tara.
Thank you very much.
Thank you for joining me and taking the balls out of the box.
Of course.
We're going to do a simple question, first of all, and then we'll get into drawing a T diagram in the second segment. Okay, so let's move on, and we're going to pick up on this question. Question number 1. How do we pronounce that?
Nazir.
Nazir. I thought it was Nazir, and I've got tongue twisted. If Nazir makes 10 dozen half-moon pastries, okay, so he's a baker, of which 75% are filled with mince and filling, and the rest with chicken filling, calculate the probability that you will choose 2 consecutive half-moons with chicken filling without replacing the first one. Write your answer in the simplest fraction. Okay, so guys, let's pick out all the information we've got to know here. So the first thing I've got to do is I've got to calculate the total number of half moons. So remember what it told us? It said he's made 10 dozen. Of course, you should remember that a dozen is 12. So the total number of half moons, just get this right, total number is equal to 10 times 12, which is 120. So there are 120 of these pastries. Now, the next bit of information is critical because it says 75%, look at it here, are filled with mince. So the rest are filled with chicken. So I'm going to calculate what 75%, I'm not going to trust my head to do this. I'm going to say 120 multiplied by 75%, and 75% is 75 divided by 100, and that gives me an answer of 90. So I know that 90 of these are mince. So mince, I've got 90. And what's the chicken? Well, the chicken will be the 25%. So I could do it in two ways. I could have just subtracted from 120, but probably the better way to do it is to say 20 times 25%. So it's 25 divided by 100, and we get 30. Now, if we do that, you will see that it does add up to 120, and I'm quite happy that it's like that. So, what's the next step? Remember, we've got 120 in the box. So, what's the probability of me choosing a chicken? Well, there are how many chickens, half moons on the plate or in the box? Well, it tells me there are 30. So, I guess for my first turn, it's going to be out of 120, I can choose 30. You with that? Does it make sense? Now, what I like to do, because they said keep it in a simple fraction, at that point, I would like to write that as a simple fraction.
So it's 1 over 4.
It becomes, absolutely. So it's 3 out of 12. So I could easily see that it's 3 out of 12. Cancel that down. And 3 into 12 goes 4 times, so it's 1 out of 4. But you know what? Peter always says, check it on the calculator. So I'm going to do just that. I'm going to say 30 out of 120, and that gives me 1/4. And I need to get it into that lowest notation as well. Now, guys, the next part that we need to understand is very important. How many are left in the box? How many are left on the plate that we've got? We've taken 1 away, so that means that the total is now no longer 120. The new total, I'm going to write in pink, is 119. Do you agree?
Mm-hmm.
And what about the chicken? We've removed 1, so it's 29. So I guess the second turn, my second sampling, I've got 29 out of 119. Ugly numbers. Don't help very much because they really are quite ugly in terms of not being able to cancel down. Now I've got to combine those. And I want you to listen carefully. What is the question? I need to take a chicken or a mince, or was it a chicken and another chicken? It was chicken and chicken. Remember, when we have the word and, because they were on consecutive, then what do we do to the probabilities? We multiply them together. So I'm going to take 1/4 from my first term, multiplied by 29 out of 119. Now, I'm not going to try and do that in my head. I'm going to use the calculator, and I'm going to say as follows. I'm going to say 1/4. Let's use the fraction button, nice fraction button on the Casio calculator, and we're going to put in the 4 at the bottom. Let's go up and put the 1 in, and then let's get out of there, move across, multiplied by fraction button, 19, and go down to the bottom.
20.
And it was 129.
Yeah.
Agree?
No,
I've got the wrong way around. I've gone and messed it up. Sorry. That should be 29 over here. Do you agree with that?
Yeah.
Should be 29. Let's just put the 29 in there. And it should be 119.
19.
I got them mixed up without looking. So, very good. And let's go out. and we can say that's going to be equal to 29 out of 476. And that's the simplest that it can be. 29 out of 476. Was that right?
I think so.
76. 76.
Oh,
there we go. 476. We've got it. Please make sure that you understand that it's and, so we multiply. Okay, Tara, let's go for a break.
Awesome. I hope you guys are finding this super beneficial. I think it's very great. We're going to take a quick break, but we'll see you straight afterwards. Welcome back, Mindsetters. We're busy with some probability, and I'm finding it super interesting. I hope you're finding it very beneficial. Before I give it over to John, I just want to tell you about another competition we've got running. You can test yourself on the work that we've covered, which I think is a great idea to get an idea of what you do and don't know. And submitting that test enters you into a competition to win a Casio calculator, and I think very useful when working with probability.
And it's super great with the fraction button as well, particularly on the Casio calculator.
Exactly, yeah, definitely. I couldn't agree more. Helped me so much. So definitely enter. So you're getting a bit of both. Standing a probability.
Yeah,
there we go to win a Casio calculator, as well as getting to know what you do and don't know. So definitely give it a try. It's up on the Facebook page, and if you have any questions, please feel free to ask. Thanks, John.
Thanks, Tara. Now, I just wanted to say one thing about the test yourself questions for tonight's section. It's all about playing cards. Now, I'm sure you've played cards.
Yes.
You know, you have the suits of different cards. There are the red ones that are the hearts, and the diamonds are the red ones, and then you get clubs and spades.
Mm-hmm.
And in each of those suits, there are 13 different cards. So there are 4 times 13, which is 52. Now, when we look at the questions on Test Yourself, if you understand about cards and you can count up making selections out of a deck, it's a lot of fun. So I challenge you, go and see how many you can get right. The great thing is that once you've submitted your question, when we close the competition next Thursday, you'll get your answers. You'll be able to see exactly what your score is. So make sure you do that. Okay, let's move on. And we are talking more about food. Now, that's no mistake. I mean, we had Peter having lunch, and now we're going to talk about a menu. Well, Peter and food kind of go together, and we can see that when we see him. I just wonder whether he's done any reduction or he's done enlargement, but we'll have to wait and see. So here in a restaurant, we're told that customers can choose from a set menu. This isn't an a la carte restaurant. They have particular things that are published. And so the menu for today in Peter's restaurant, you can either have rump strips as the starter, or you can have mushrooms, or you can have chicken wings.
Yum.
You can't have all three. You can have this one, or that one, or the next one. You got it? Just make sure that you understand that you can only have those 3. When you come to the main course, you can have either roast chicken and veggies. That doesn't mean roast chicken and veggies, but it's one dish, or a pasta dish. So you've got a choice of 2. So the next thing you need to see is we go to dessert. So you can have ice cream and chocolate sauce, or you can have apple pie and cream. Now, there's quite a lot of choice there. Eh? And because you're paying one price for all of this stuff, you want to make sure you get the best choices that you want. And how many choices are there? It's quite complex, eh? So what we need to do is, the question asks us to draw a tree diagram. A tree diagram illustrating the probability of choices available to the customers. So I'm going to go to the next page, and where there's some blank space, and I'm just going to make this a little bit smaller because it's got a bit big, and put it in the middle, and let's see how we can go. It's still a little bit bigger than I want it, and there's the menu. I'm going to There we go. That's much better. So there's the menu. We're not going to forget it. So if I start at a particular point, I'm going to start over there on the page. And I'm going to say, at the starter, this is the starter. I've got 3 possibilities. I can either go 1, or I can go 2, or I can go 3. So what was 1? 1 was the rump. So this is, I'm going to just write on it so we don't forget. This is the rump. And the number 2 was the mushrooms. So I'm going to put mushrooms over there. And the number 3, what was number 3? Was chicken wings. So I'm going to put CW. So there's chicken wings. Okay? I can't choose all of them. I can choose either the rump, or the mushrooms, or the chicken wings. Now, at that point, my tree diagram is looking just like a foot. It's not really looking much like a tree. But what I need to recognize is at the end of each of these points, I've now got to make a second choice. And this is for my main course. So over here, how many options were available for the main? Well, you can see there was either chicken and vegetables or pasta. So at the end of this, what I can put down, and I just want to change that because it's not looking the way I want it to. I can put down like that. I can put a white line down like that. Or I can put, and I'm going to change the color of this one, I can put an orange line down like that. But let's just make sure that it's not as dotted. And we just change its form and make it a bit fatter. So there is the choice. The first one could be the chicken, roast chicken, and this one was pasta. So I've got the choice of those 2. But it's not just that. I can choose those same things depending on what starter I've got. So I'm going to take that one and put it over there, and take this one and copy it and paste it down and put it over there. So now my tree diagram is growing. It's got more branches on it. Let's do the same thing for the bottom one. So I hope you can see this is giving us more and more options in terms of what we are doing. And we're going to be able to count how many possible routes there were to get to the end. And let's paste it, and we've got it there. But now, guys, it's getting quite full, but I hope you can see that we're not done yet. Because what have we got after this? We've got the dessert. And we're running out of colors of lines, but that shouldn't be too much of a problem because we can always go to this palette and change them. So I'm going to make that line that, and let's make sure that it's the right thickness. And let's take that, and we're going to put that on over there, the blue line over there. And what color haven't we had? Well, I'm just going to use the pink one again and put that one over there. And I'm going to use the pink one over there and take the blue one. Let's take the blue one and copy it. Where is that? So there we go. And you see, I didn't do this.
I always used to have this problem.
Carefully enough in terms of making space available. And you can see I haven't done enough practice on this, but we're getting there. So don't panic if it's starting to look a bit of a mess, because it generally does. We're putting in the next line, putting in the blue line. I like to do different colors because then that helps me make sure that I've counted each one, and get there for that one. And let's pick that one again, pick that one and clone it. It's not wanting to be cloned. There it goes. And you know what? I'm just going to pick that one. No, let's do this. Do that. And last thing, I need to do is select the blue line, copy it, and paste it again, and put it into place. But I don't want them overlapping. Try not to get them to overlap. And there we go. Okay, the machine is crying out, don't do this to me, but we've done it. Now, that was quite complicated, but I think that the tree diagram shows us quite nicely how many different options you've got. Let's count them. And what we're going to do is we're going to count the endings so we can see exactly where we are. So the first option would be to start with the rump, then have the roast chicken, and then have the chocolate sauce and ice cream. So that would be one. This would be the same except you're having the apple pie. This one, you've chosen the pasta, but you're doing the ice cream chocolate sauce. And so you can see 3, 4, 5, 6, 7, 8, and wait a minute, 9, 10, 11, I'm going too quickly, 12. So on this menu, there are 12 options, 12 possible different scenarios that you could have. So you could go there 12 days and have a different meal each day. Isn't that amazing? Think about it. Okay, having completed the tree diagram, now let's have a look at what the questions say. We're going to come back to that tree diagram. How many combinations are available to a customer? We've worked them out. 12. We've got it. Now, here is the interesting question. The chef would like to know, what is the probability of someone having mushroom, roast chicken, and apple pie? Okay? So let's go and look at that on the tree diagram, and let's take a look and see exactly what the probabilities are. So the first thing that we need to recognize is that that's the yellow mushroom is that we're looking at. So what's the probability if he randomly selected? How many starters have we got? Well, we've only got 3. So to get the mushroom, it was a choice of 1 out of 3. Okay? Because he had to have, it was either the rump steak or the mushroom, or what was the third one?
Oh,
it was chicken wings. Yeah. Now, what's interesting is if you do this and you put them on and you say 1 out of 3 plus 1 out of 3 plus 1 out of 3, because it's a choice, you can add them together and it gives you 1. Okay. So that's a nice little tip in each section that you can get. So what was the second thing that the chef wanted to know? The second thing that he wanted to know was that this person had chosen roast chicken. So let's go back to it, and let's see now, in each of these, he's got to have a choice of 1 out of 2. So we're going with the roast chicken, and we're saying that's the roast chicken. He's a choice of 1 out of 2, 1 out of 2 over here. Now, if we do this, what you will recognize here is that it wasn't that in this line, he's got 1 out of 2. In this line, it's 1 out of 2. In this line, it's 1 out of 2 as well. In this line, it's 1 out of 2. In that line, it's 1 out of 2. They've had to make those choices. So we're moving on. Now we come to the last choice. We've got a choice of, again, 2 choices. 1 out of 2, the ice cream and chocolate sauce or the apple pie. The one that we want is going to be this line here. We're wanting to have the mushrooms, the chicken, and the apple pie. But now notice something here, guys. It wasn't you could have the mushrooms or the roast chicken. It wasn't the mushrooms or the roast chicken. It was the mushrooms and the roast chicken. And so if we want to show our working here back on the page, what we've got to do is we've got to say, we know that to get the mushrooms was a choice of 1 out of 3. and the chicken was 1 out of 2, and the ice cream, or not the ice cream, the apple pie and cream was 1 out of 2. We multiply because it is an and. And when we do that, 3 times, let's not do it over there. I would perhaps do it on the calculator. I mean, in my head, but Peter won't enjoy that. He says, use the calculator. So let's use the calculator. 1, 3 multiplied by 1 out of 2. Now, I know 1 out of 2 is 0.5, so I'm going to put 0.5 multiplied by 0.5, and we get 1 out of 12. Now, 1 out of 12 is my answer. Now, does that seem a long way around to get to that answer? Well, yes, it is. If we go to the tree diagram, we could have got that right from the beginning, because we would have seen that if we look at the tree diagram, there was only one root, which I've highlighted here, that gives me exactly 1 out of these 12s. It was combination number 6. There were 12 possibilities, and I've chosen 1 out of 6. Okay, 1 out of 12 at least. Number 6. It's unique. One possible combination. 1 out of 12. But I've done it by looking at each stage, and I've multiplied the probabilities at each stage, and it gives me the same answer. So it's a really nice way of checking it. Okay, let's move on, because the next question is a little bit more complicated, and I know that I'm going to need some space. So we'll get to it now. So what is the probability of a customer choosing the rump strips, either the chicken or the pasta, and the apple pie or the ice cream and chocolate sauce? So now, guys, what I'm going to do is I'm going to do it in a different way. I'm going to do it by looking at the tree diagram. So let's have a look at the tree diagram and see what we're going to. Taro, do you think you'll remember this? First step, rump strips.
Okay.
Okay. And then the second step, it's either the chicken
Yes.
or the pasta. And the last step, it's either the apple pie or the ice cream and chocolate sauce. So let's go. I'm just going to erase all of the things so that we can start again. And we've got our basic tree diagram, and I'm going to be working with the top half because we're going to make it work like that. So, guys, first step, we have to take the, what was the first thing he chose?
Rump.
The rump. So that was the rump. And then I want you to see he could take either the chicken or the pasta.
Yes.
Agree? And then he could take either the ice cream or the apple pie.
Yes, yeah.
So I, A, and that's it.
Yes.
So can you see how many there are just by looking at the tree diagram? Because we had to take the rump, that was compulsory. Then we could have done a selection. It was this one or that one, and then this one or that one. And that means this one or that one. So the total number of possible things that he gets that would give him the right combination is 1, 2, 3, 4. So how many possibilities were there overall? How many possibles were there? We said there were 12 possible options. And here, 4 of them are on the chef's list of possibilities. So 4 out of 12 gives you 1 out of 3 as a probability simplified. Let's check if it does work. I'm going to leave you to do that in the break. And the way that I want you to do it is I don't want you just to mark it here like this. I want you to do the calculation with the and the or. So choose what's the probability for this one. This one will be 1 over 3. What's the probability over here? This is 1 over 2. That's 1 over 2. And this is 1 over 2, 1 over 2. So you can do the additions and subtractions and see if you get it sorted out. Okay, now have a look at that, make sure that you're comfortable, and let's go to a little break.
Definitely. I know all the speak of food is getting my...
It's starting to
so
rumble. Yeah.
I'm sure it's the same with you guys. So get something to drink, get something to eat, but join us straight after the break. Welcome back, Mindsetters. I hope you had a good break and you're ready for some more probability. Before we get started, I want to just congratulate 2 of our Mindsetters who won the Casio calculator. They entered, tested themselves and entered a competition to win the Casio calculator. Our 2 winners are Julieta Aurelio, sorry, forgive me for if I've mispronounced it, and Siku Mahai. Well done, guys. And I hope you enjoy your calculators. And for the rest of you, it's so simple. Get testing and see what you do and don't know, and it stands a chance for you to win a calculator. Thanks, John.
Now, Tara, the reason that there are 2 is the week before there weren't enough winners. So we said the pool was too small. So guys, make sure that you enter tonight. Remember, the questions are all about playing cards. And so if you play the card game, make sure that you calculate the probabilities, because that could help you, and it's something that can come up in the final exam as well. Right, now we're going back to our tree diagram, and we've got one last question to deal with. We don't want to spend too much longer on it, but let's have a look at what it says here. It says, in this whole menu, 1 apple pie, we have to talk about food again, gives 8 servings. So the restaurant manager sees that for Saturday, he has 72 people booked. Based on probability, what is the minimum number of apple pies he needs to order to make sure that the customers get the dessert they want? Wow, that's an interesting question.
Definitely.
Eh? Okay, so let's go back to the tree diagram, and let's remember something, that the light blue ones represented apple pie. So if you chose this option, that's 1 that needs apple pie. That's 2 that needs apple pie. That's 3 that needs apple pie. That's 4 that needs apple pie. You can count down. That's 5 that needs apple pie. And that one didn't get erased. That's number 6 that needs an apple pie. So in a way, it's not difficult to understand that the probability is 12 out of 6. Because 6 out of 12 at least. 12 options, 6 of them have apple pie. So the probability is about 0.5 or 50%. But now, that's if everyone has pudding. If everybody decides to take dessert, then you must make sure the minimum that you have, 50%. So how many is that? Look at the question. Don't just leave it there. So what's the minimum that he needs to have? Based on probability, because the probability is 50%, he needs to make sure if he's going to have 72 guests, remember, half of them are likely to have apple pie. So 72 times a half gives us 36. So he needs to have 36 servings of apple pie. And if each apple pie gives 8 servings, then what we're going to do is we're going to say, let's take 36 divided by 8, and you can see that it's just over 4. In fact, it's 4.5. So he needs to make sure that he has at least 5 apple pies. He's going to need 5 apple pies. And you know what? If I was him, I probably would have an extra one just in case. Because you never know, people might actually like apple pie and cream more than they like chocolate sauce and ice cream. Although I think there's much of a muchness between them. I certainly would want either of those. I'd be quite happy. Okay, let's move on now to the challenge question. Had some time to think about it? DJ sitting there in Disney World, having his lunch order. He would really like the chef special. Dad can't make up his mind. Mom can't make up her mind. So what are they going to do? They decide to put in numbers into a hat and start to do some drawing. So how many numbers did we have in the hat to start with? We started with 32. So there were 32 pieces of paper to start with. How many could Peter take out in that first draw? Clearly, 1. Okay. Now, what you need to understand is there was 32. That was one of the things that DJ might have liked. He could have the burger that comes out of draw 1. They're not going to allow him to have burger 1, burger 2, and burger 3. So it's not an and calculation. What about the second one? Well, the second one, if the first one isn't the number 10, the chances of the second one being a number 10, it's 1 out of, is it 32 still? No, Peter's taken out the one piece of paper. So how many have we got left? We've got 31 left. And the chances next, because remember, DJ's either going to get the hamburger from the chef special from draw number 1, or from draw number 2, or from draw number 3. You can't have, there's not going to be a chef special in all 3. Okay? So that's why we're saying plus. Plus 1 out of 30. So let's take the old calculator and let's see what we can do with these numbers. So here we go. We're going to use the fraction button again. 1 out of 32. So if we just look at that, just for as a matter of interest, 1 out of 32 as a decimal gives us 0,031. I just want to write this down as a percentage. Multiplied by 100, because we want to just compare it. 3,125%. Okay? Percent. I'm just doing another little side calculation. Let's look at the next one. 1 divided by 31 equals multiplied by 100, and let's work that as a percentage, and it's 3,2. 3,22. Well, let me make it 23. 3,23%. And then 1 out of 30, clear? And say 1 divided by 30 just works just as well as the calculator, the fraction button. This multiplied by 100 gives us 3,33. So what I wanted you to understand and what I wanted you to see is that as the pool is getting smaller, the number is getting smaller, the chances of us getting the one that we want increases. Remember, we demonstrated that right at the beginning. We wanted to get the blue ball, and only when we got when there was one ball left did we know there was a certainty of getting the green ball out of there. But as you can see, the number in the box decreases, so it goes from 32 to 31 to 30. What's happening to the percentage probability of getting the one that he wants? It's becoming bigger and bigger. So what's our next step? Well, the next step is to add these together. And let's just use the calculator as we should do to do that. And we're going to do the original calculation, 1 out of 32. Remember, it's OR, so we're going to say we want to plus to that probability 1 out of 1 divide. If you make a mistake on the calculator, just carry on. Plus fraction button 1 out of 30. And let's see what that gives us. It's a very big number, not a very interesting number, but if we multiply it as a percentage, multiplied by 100, what do we get? As a fraction, 9,68%. 9,68% equals 9,68%. So, not too bad. He's got about a 10% chance of getting the burger that he wants. Interesting, eh? So if you can't decide in a restaurant what to have, throw some numbers in a hat and make a choice. Tara, are there any questions on the page?
There is a question. It's just referring back to what we were doing before the challenge question. Brian doesn't understand why there is a 1/3 by the starters and a 1/2 by the rump, mushroom, and chicken wings.
Okay, let's just have a look. In the tree diagram.
Yeah, I would assume so.
Okay, so look here. For the starters, it's 1/3. For the chicken, it's sorry, that was the rump. For the mushroom, it's 1/3, and for that. But now when we get to this selection here, we've only got another 2 choices, haven't we?
Yes.
So when we get to this point here, we can either take the chicken, the roast chicken, or the pasta. So how many ways can I choose my main course? I can only choose it in 2 ways. So that's why I've put the 1/2 there. And then in the same way, I can only choose ice cream and chocolate sauce or the apple pie over there. Okay, Brian, I hope that helps you. Hope you can get the idea that in the end, we've got the total number of choices correct. Okay. Any other?
No, that's it.
Okay, there was one other question, and that was, what would happen? What's the probability of winning the lotto tomorrow night? When I had to answer that there's no chance of winning the lotto because the lotto isn't on tomorrow night. And guys, even if it was on, the chances are so small. But if we did win the lotto, I don't think many of us would stay at work. But for you guys, make sure that you study hard, do your best, and make sure that you've got probability all wrapped up. Remember, if you've got more questions, send them to the help desk. Tara, it's been great being with you this evening.
Thank you. You too, John. I hope you guys found this very beneficial. Listening to it again and seeing it again brings so much back, and I hope that you managed to get as much out of this session as you could. That's all from me for today. Make sure you enter the competitions. There's so much to be won, and I really look forward to hearing from you guys if you have any questions. Thank you again for joining us, and we'll see you soon. Bye, guys.